Okay, good morning, everybody. Welcome to another week of CS40. Good news for everybody, for at least for most people, that these past 2 weeks we've been talking, so again, using this analogy between Python and foreign languages that you might have studied previously. So far, we've really only been talking about grammar, doing grammar drills in our new foreign language of Python. And nobody likes grammar drills, but good news is this is basically our last week of this sort of grammar drills, just getting the pieces together of how things work. And after this sort of 3-week period, we're going to have all the knowledge that we'll need to start looking at actual, really cool Python things that aren't just grammar drills, but getting into cool applications and things. So yeah, bear with us for just one more week, and then we'll be getting into the more fun stuff after this. Yes, if there's 2 handouts for today on the website. They're on this Ascii conversion cart.pdf and this quiz practice.pdf. They look something like here's the big Ascii conversion chart. And let's see, here's our practice quiz for strings today. This week, we're going to be going over strings and how Python and programming languages in general store text on the computer. As a reminder, this practice quiz material for strings, this is what we're going to be going over today for the most part, but you have a quiz on Wednesday, so the next class period, that's not on this material, not on the stuff we're talking about today, but is instead on the containers. And in particular, this focuses on the lists. We'll see today that a lot of the material related to strings is very, very closely related to lists. And so some of the things that we talk about today, like indexing and slices, will help you also review for the containers quiz. But the material from today that we'll be talking about, not at all on the quiz on Wednesday. Last sort of administrative announcement is that last week we had our second quiz in this class, and these first 2 quizzes you're allowed to retake without any penalty. But again, you have to retake it before the next quiz happens. So you have to retake it before Wednesday. If you do choose to retake it, then whatever you get on your retake is going to be what I enter into Sakai for you. Even if you do worse on the retake, that's what gets entered into Sakai. So you should prepare and make sure that you study for the retake as if it were a real, regular, normal quiz. I'll be available for people who want to retake either after class today or during my office hours tomorrow, or if neither of those times works for you and you still want to do it, then make sure to set up with me over email an alternative time. Any questions about anything administrative, any of that sort of stuff before we get into talking about strings? Okay, everyone's just excited to talk about strings. That's great. Woohoo! Okay, so again, anytime we're going over material in class, recommend having your Python cheat sheet out in front of you so that you can take notes on this. You'll have access to this cheat sheet during all of the quizzes, and even professional programmers have cheat sheets like this just taped to their wall around their computer so that they can look stuff up really quickly. Because again, we are lazy people. We don't want to waste our brain cells memorizing this sort of stuff because paper is much better at memorizing than people brains are. For the important boxes for today are this sequence containers indexing. We'll be talking about things like slices and indexing on strings now instead of just lists. And all of that works exactly the same. So this sequence containers indexing box right here will be our reference for that. And then way down here on the second page in the bottom right corner, there's this operations on strings. It's in sort of goldish color in mine. This will also be our reference or important box for today. We'll be going over a lot of these functions today, not all of them, but a lot of them. And this would be a good spot to just make notes on some of the caveats and weird things, weird behavior with these different functions. Here we go. For this quiz material, rather than loading stuff up into Python Tutor, I'm going to be doing stuff directly in VS Code and directly in the terminal interactive Python down below, because we'll be able to get faster feedback on things. And for the most part, one of the things that's different about the strings sort of material than the other material is there's not a whole lot of like step-by-step walking through how something works. Instead, the material is going to be, there's a lot of weird function calls, and we'll just have to understand what are those functions doing. So Python Tutor is going to be a little bit less helpful for strings than it was on the other two labs, or the other two weeks of material. So coming over here into VS Code, there is a notes.py for this week. We probably won't get to that today, and that'll be for Wednesday. And so down here, I'm just going to make my terminal window a little bit bigger. Again, as a hacker or a computer programmer more generally, I'm all about efficiency. I want to make the best possible use of my screen real estate. And so you'll notice up here on my screen, you can't see my desktop. I don't have like this window in some sort of like small thing like this so that I can only see a small piece of screen, and I'm wasting all this screen real estate. We all know real estate's super valuable here in Southern California, so we better make as good use of it as we can and use up our entire monitor like this. In order to get into interactive Python, always when you have a Python file up, you can press the triangle button like this, and that'll run your Python program, but that doesn't go into interactive Python. In order to get into interactive Python, you find these spots right here where the big long, what we call the path to your Python program. It'll come after your prompt and before the name of the file that you have open. For mine, it looks like this. For yours, it'll probably be longer. And you just copy and paste that right here, press enter. And now I know I'm in interactive Python because I have the 3 greater than signs right here. Anytime you have the 3 greater than signs, and that'll be the same for everybody's computer. Anytime you see this, then you can type in Python and it will just work. Any questions so far? Yes. The question is this beginning part over here, how did I get that? And the answer is that for your computer, it's going to look different than my computer. This here is called the prompt. The prompt usually or traditionally ends in a $sign. Windows does things a little bit differently, and so your prompt might end in a greater than sign or a parentheses like that, other common things for it to end in, but it'll be whatever your line is sort of all by itself. Whatever that is, we call that the prompt. It's prompting you to type something in, and so you press the triangle button and take whatever is the immediate thing after that that ends in Python 3 and paste that, and that'll get you into the interactive Python mode. Yep. Okay, let's take a look at this first problem over here. In Python, we know we have a string because we have these single quotation marks. I'll make this a little bit bigger for us. These single quotation marks are the delimiters for a string. They mark the beginning and the end of the string. And so I can do something like s equals hello space world like this and hit enter, and it creates this string for us. And we've seen lots of examples of strings so far, especially in our print statements. We just haven't talked about them yet in detail. If you compare in Python over here, like in the actual terminal, when I'm actually typing in Python, you can see that I have a space between hello and world. There's nothing that actually gets displayed right there. When we print out strings that are part of Python code, like printed out on paper, it's customary to actually like print the space so that you know how many spaces there are. And so there's this little like cup looking thing between hello and world. When you see that cup looking thing printed out, that means there's a space right there. And you know there's exactly one space right there because there's exactly one of these little cup looking things. In Python, I always use single quotes for all of my Python strings because I am lazy and I hate the shift key. My pinky gets really, really tired. And so I don't usually do the double quotes, but there's absolutely no difference between single and double quotes in Python. So some people prefer double quotes. I prefer single quotes because I am lazy, but these two things are exactly the same thing. And actually, you notice if I hit S like that and just ask it to print out what is the value of this variable, you'll see that Python by default puts strings in single quotation marks when it prints them out because all Pythonistas are inherently lazy. This is just this subtle message that you shouldn't be, don't make your pinky do extra work. Here, this indexing into strings works just like it works in lists, that you start from the left counting at 0. So this H right here, S at position 0 or S square bracket 0 or S of 0 or S index 0, all those things equivalent to each other, gives you that very first letter over here, this H. And similarly, if we were to do the -1, we start counting from the right, that would give me the D over here. So this is indexing. Slices are also something that you can do on strings. So here, if I only want to get this world over here, I can count up to where would the W be and go, okay, that's 0, 1, 2, 3, 4, 5. Okay, the W must be position 6. Let's just double check that. Yes, S at 6 is W. S at 6 colon gives me world like that. So you can extract substrings. We call this right here a substring of this full string over here. Slices get you substrings of full strings. And again, the slicing and the indexing all happens exactly the same way as it happens in lists. So in order to understand, or in order to be able to predict on a problem like problem number 1 up here, how these slices are working, you should use the container sequence containers indexing box up here to remind you that you start -1 from the right, going smaller and smaller to the left, or 0 is the leftmost one. Any questions so far? Okay. So that's one of the similarities between lists and strings. And now I want us to talk about some of the differences between lists and strings. And this is something that is very, very easy to get confused on. So the next sort of these quiz problems down here are about that. And so here I have a string S 1, 2, 3, 4, 5, and this XS 1, 2, 3, 4, 5 as well. And we'll see what happens between these. So first thing I want to do is to check, does S equal to XS? They contain sort of somehow the same information or very, very similar information, but they're not actually equal to each other. Anytime you have two values of two different types, like a string and a list, they will never be equal to each other, even if they contain the same information. So this S and this XS not equal to each other. Let's see if we look at S at position 0, we'll get a 1 out. And if we do XS at position 0, we'll also get a 1 out. And so let's try doing S at position 0 equals to XS at position 0 like this. And I'll hit enter. And you can see that I still get a false out here. Even though this got me a 1 and this also got me a 1, they're still not equal to each other. And the reason for that is that this S at position 0 right here, you can see that it's inside the quotation marks right here. So it's actually still a string. Anytime you index a string, and I'll type this out, anytime you index a string, you always get a string out. So here, it looks like there's this number 1 right here. It looks like there's this number 1, but it's not actually the number 1. It is just the string containing the number 1. And the string containing the number 1 is not equal to the number 1. Here, this looks like the number 1, and it is in fact the number 1. And so if I did XS at 0 equals 1, that is in fact equal to 1. We do get true. So very important when working with strings that just because you're like it looks like a number inside of it, it's not actually a number inside of it, that it's still a string, something totally different. We'll do a variation on this real quick. So again, the current XS has all numbers inside of it. I'm going to create a variable YS. This is not inside of the quiz at all, but this is a good thing to keep in mind when you're thinking about this. Now this variable YS has the same or very, very similar elements. YS is very, very similar to XS in that they both have a bunch of number-looking things inside of them, but the YS has actual strings inside of it. I know they're strings because they're surrounded in quotation marks. And even though it looks like a number inside that quotation mark, it is actually a string of the number 1. And so now S for string, S at position 0 is the number 1 surrounded in quotation marks, so it is the string 1, and YS at position 0 like this, also the string 1, and so I can have S at position 0 equals YS at position 0, and that'll be true because they're both strings inside of each other. So as you're doing these, the takeaway message here is that as you're doing these indexing and slicing operations, whether it's on the quiz or on the labs and the projects, you want to be very, very careful to what's inside of the lists over here, because what comes out of a list can be anything, but what comes out of a string is always another string. Anytime you index a string, you always get a string. Question, Mara? Very good. Yep. Any other questions about strings or lists, difference between them so far? Okay, so back over to this, these problems, these first 2 problems, or this problem 2 and problem 3, now just testing these differences between strings and lists. Problem 3 gets a little bit interesting because here we have a string, and now we have a string inside of a list. So let's go ahead and recreate that down here. Give us some blank space right here. S equals hello, and XS equals H, E, L, L, O, like that. And now if I did SS at whatever position like that, I would get a string out. You always get a string when you access a string. And if I did it at XS, I get the same thing. SS at position 0 equals XS at position 0, like this. That is true. But what the problem is actually talking about is slices and not indexing. Anytime you slice a string, you get a string. And anytime you slice a list, you get a list. And so if you have slices and you compare them to each other, a string and a list, they can't possibly be equal, because the slice of the string, do 3 colon like that, gives me a string out, but the slice of a list gives me a list out. And so even though SS at position 3 equals XS at position 3 like that, S at the slice that starts at position 3, does that equal the list that starts at position 3? The answer is no, because this over here gets you a list out, and this over here gets you a string out. So these are very, very sort of subtle things that you need to remember. And again, starting next week, we're going to be having getting into more of the cool applications, and we'll get big Python files that maybe have 100 or even more lines of code that you'll all write yourself, and they'll be buried inside of them, little things like this, and you'll just have to be able to look at it and say that oh, that's a mistake, because you never want to compare a string slice and a list slice, because that's never going to be true. The more of these sort of gotchas that you have in your bag of things that you can spot as things that you don't want to do, the much faster your bigger projects are going to be. Any questions? Strings versus lists. Okay. One of the interesting things about strings is that they have a bunch of sort of built-in functionality. And one of this built-in functionality is this in keyword. So here on problem 4, I have this string that says Python is awesome. So down here, we'll say s equals Python is awesome, like that. And there's a bunch of functions or functionality that I can do on this string. Here, if I say s in, whoops, was Python in s, like this, it's going to search through this string and see, hey, is this substring anywhere inside this main string? And the answer is yes. The word Python is right here, so we get true out. If I were to say something like reptile in S, then reptile is not in here, and so we get false out. This, one of the common mistakes that students make here, so this is a good thing to like make a note about, is that this in is not looking for individual words. So even though right here I typed the word Python, it doesn't have to be individual words that I'm looking for. I could say something like py like this. Py, there's no word py anywhere in here, but there's py right here. I could say like s space a. This isn't even a word. This has no sort of semantic meaning in English. What is an s space a? I have no idea. But in this string up here, there is in fact an s space a in the string. And so when I hit enter right here, we get true. If I change this to s space b, there is no s space b anywhere in the string at all, and so I get false. So the key gotcha here with this in keyword is that it doesn't have to, it's not looking for words, it's just looking for, is this thing anywhere inside of here, even not matching word boundaries. The next key gotcha with this in keyword is that it is case sensitive. Everything about strings in Python is case sensitive. And so again, s is Python is awesome. If I do lowercase Python in s like this, it's going to give me true out. But if I change this lowercase to be an uppercase right here, like that, so uppercase Python in s, we get false out. There is no uppercase Python in this string up here. There's a really easy way both to miss points on a quiz and to spend like hours and hours frustrated at your code. It's not doing what you think it should be doing because you're forgetting that Python is case sensitive. And so guarantee on the quiz for this, there's going to somehow be like case sensitivity involved. Yes. Great question. What if we had multiple spaces? So here, let's redo this example. At my string s is Python is awesome. And it, coming back up to, we did s space a in s like this, and the answer is true. If I were to add multiple spaces like this, the answer would be false because this does not match exactly something up here. If I were to change my s variable to be Python, lots of spaces is, lots of spaces, awesome like that. And now try this s space a and s, we'll get false because it's looking for exactly this string right here. And so that's why when we print out Python code, when we print out the contents of strings, we always put that little cup right there. Instead of just printing a space, it prints the little cup so you know exactly how many spaces there are inside of strings because it's important semantic information that you need to know in order to be able to answer a problem. Great question. Any other questions so far?
Underscore. So what is that thing?
The question is, what is that thing? And the answer is that it doesn't have a name. It's just the cup thing that gets printed. Yeah. I guess so. If you're, this is not a class on typesetting. If you were a typesetting person, though, that is actually literally a space that just has ink associated with it. Most spaces are just white space, but that is a space that has the little cup shape is what it looks like. Yeah, there is no character on anybody's keyboard anywhere in the world that corresponds to that except the space bar. So this problem 5 is going over the capitalization of Python right here. Again, lowercase, uppercase, lots of situations where that can trip you up. So pay close attention to that. Now, problem 6, we're getting into more functionality about strings that's very useful, like this replace function right here, s.replace. So let's make our s again, Python is awesome, like that. And let's see what happens when I do s.replace. And I think, so it says replace Python on the left with everything on the right. We go to Legoland a lot with my kids. They sing the song "Everything is Awesome" all the time, so that's always stuck in my head. So replacing Python with everything right here, and I hit enter, and you can see that it finds the word Python right here and replaces it with everything. Couple of key caveats to remember with this replace function is first, again, it is a case-sensitive function. So if I replace this Python with an uppercase P right here, then it's not going to work. It's not going to change anything. We'll still get Python is awesome instead of everything is awesome. It's only the leftmost part over here. It's this first argument right here to replace is what we're looking for. It's only the thing that we're looking for that has to match exactly. The word everything doesn't appear anywhere in this string. And so everything can look like whatever we want it to look like. It could be some weird, crazy mixture of uppercase and lowercase. That's totally fine. And it'll just put that same weird mixture over here when it does the replacing. And again, this replace function does not work on words. This replace function works on any arbitrary sort of substring of things. So if I changed Python to just pi like that and replace pi with cy like that, then we get Python is awesome. Turns out Python is another programming language that's related to Python, but it's not Python. So yeah, 2 key caveats so far. The first one, case sensitive. The second one, not operating on individual words, just operating on parsed words. The third caveat for this is that it doesn't actually change this underlying s variable. Notice that if I do s here again, we'll still get back Python is awesome, even though I've done a bunch of replaces. And this is something that every week from now on in the future, at least somebody in this class, at least one person, probably like a dozen people every week, is going to get tripped up by this. The replace function does not actually change the underlying string. In fact, no string functions modify the string. And so just because I said s.replace, it doesn't change the value of s. It doesn't actually do the replacement inside of the s variable. Instead, it creates an entirely new string with where this replacement has happened. So if I wanted to somehow store the results of this replacement, like changing Python into everything, then I have to create a new variable, set that equal to the result s.replace Python everything like that. And now this new variable t will contain the everything is awesome. If I have, and the s variable totally unmodified. Sort of the key word in programming languages about a type or a thing that never changes is we say that it's immutable. So strings are immutable, which means that they can never change. No matter what function you apply to a string, it is never going to change the contents of that string. Question?
Yeah, sorry if I missed this, but if you replace, like if you were to replace every E, or if you were to try to replace E, replace every or the first E?
Fantastic question. So the question is, all the examples that I've done so far is it's matched exactly one thing inside of this list or inside of this string up here. What happens if we want to match multiple things? And so in particular, we have 2 E's right here. What happens if we do s.replace E, and we'll just replace it with a bunch of X's up capitalized so we can see how many they are. And you can see that it does the replacement everywhere, not just at like the first location. If we come back to our Python cheat sheet, let's take a look at down here in this operations on strings. Where's this replace? Oh, replace isn't in this box. So this is a good thing to make sure that you add onto this box down here is that replace. And it's the first thing is the thing that you're looking for. The second thing is the thing that you're putting inside of it. And then, yeah, so related to that, if we have no matches of something, then it just leaves the string alone, doesn't do anything. Great question. Any? Yes.
So assuming the S, so you can name the string T, originally be T dot replace.
Exactly. So now let's say we have this T variable. Everything is awesome. If we do T dot replace is awesome, comma sucks like that, then everything sucks. Then it's applying it to that particular T variable right there. And so there's our S. If I were to change that T to an S like that, then you get Python sucks, which I don't feel that way. Computer doesn't feel that way. Maybe you feel that way. But whatever is to the left of the dot is the string that you're doing it on. And then the first thing over here, what you're replacing and the new value that you're adding. Freya.
Instead of T assign S dot replace to S again, would be an error or would it override the initial?
This is a fantastic question. What the question is that previously I had something that looked like, so let's separate things out so we can see a little bit better. There's our S Python is awesome. And then I did T equals S dot replace Python, everything like that. And now we have this T variable. The question is, what happens if I do the S equals S dot replace? This is 100% allowed in Python, and it will, now this previous S variable is now everything is awesome. It's done the replacement. So this is a common pattern in Python. It's a common idiom or pattern to say that like whatever your variable is equals that variable dot replace. And that's how you actually update a string in Python. The function itself will never update the string. If you want to actually update it, you have to say blah equals blah dot replace. Great question. Yes. Yeah, so here in problem 7, we do S dot replace like this. This doesn't actually modify S at all. So it stays as Python is awesome. And here we have actually, there's 2 reasons why it stays as Python is awesome. One is that there's a mismatch in the case right here, that this Python with the capital P doesn't match this Python with the lowercase p. And the other reason is because it doesn't actually modify this variable.
Why do you have S equals there?
Down here on the print statement, that's just displaying it. Yep. Okay. So everything that we've talked about so far, not operating on words inside of Python. But what if we actually did want to somehow like operate on words? English, most languages divided into words. How can we get those words out? And that's what problem 8 in the split function is talking about. So again, S like this, everything is awesome. If you do S dot split, like that, hit enter, then the split gives you a list of all the words in the string. Everything is awesome. The split function by default, let's see. So this dot split function you can run on a variable like this, or you can run it, all of these string functions, you can run them directly on the string itself. So I could say Python space is awesome dot split like that, and that's totally an okay thing to do. I'm gonna press the up arrow, come back over here, and let's add a whole bunch of extra spaces in between this, and we'll see what happens. And I'll hit enter here, and you can see that it doesn't matter how many spaces that you have in between your words, Python is still going to identify that there's just 3 words right here, and that's what they are. If you have punctuation anywhere, So like Python is awesome, exclamation point. Make sure everybody understands, and we hit enter. That exclamation point, because there's no space between awesome and the exclamation point, it's still considered like one word from the split function's perspective. So the split function doesn't know like anything about English language or whatever language you're working in. All it knows is that it splits on these white space values like this. There's a number of other types of white space in Python that you need to be familiar with. So right now what I'm doing is I just pressed the tab key a bunch of times. And when I press the tab key, you can see that in Python, it gets displayed as this \t. This backslash right here, let's see, a couple important notes here. So that is a backslash. It's above the enter key on a US keyboard. And that is a /. It's below the enter key on the US keyboard. The backslash, that in Python and most other languages is what we call an escape character, which means that it somehow does something special. And so if we have \t like that, \t is somehow something special. And the T happens to stand for the word tab. So the \t equals a tab. If I do, there's going to be a lot of things like going on here, and it's easy to miss like one of these tiny steps, and then the whole like picture doesn't come together unless you see all the steps. So now it's a good time to like focus and try to make sure that you see all the subtle differences between what I'm about to do. So if I have a string by itself, it'll be t like this. And now there's t\tt, it prints it out exactly as I have up there. But if I use the print function, instead of just displaying it by itself, print t\tt, then the first t gets printed like this, and the \t right here gets interpreted as this tab, like as if you press the tab button on your keyboard and you jumped out a couple of spaces. By default, it's 8 spaces. And then this other t over here corresponds to this right here. So this \t here tells the print function, don't just print out a \t, actually print out a tab instead. There's a lot of these sort of special characters that can be really hard to like manually enter on a keyboard in certain situations. And so in order to make it easier to enter them, we have this special / character that lets us enter them. One example of something that's particularly hard to enter is \n. \n stands for new line. It's like hitting enter on your keyboard. And when you do that, then the \n here actually gets interpreted as if you hit enter, and it prints out as multiple lines down here. So the reason like \n is hard to work with is because if you hit enter, if you actually hit enter on your keyboard, Python's going to run it. And so it has this special \n that you can use instead if you want to get the \n printed, if you want a new line printed. If you literally want a \n printed, then you have to do \\. Indicates that this is nothing special going on here. \/ is literally just the \ character. I hit enter and it does t\n. So in summary, if inside a string you see \t, that's a tab. \n is a new line, like hitting enter. And \/ is actually one \. So up here, even though I was printing out and it had 2 backslashes in here, it interpreted that as a single \ right here. This is all, the print function actually does what we call the interpretation of these escape characters. If you don't have the print function, then you're just going to get like what you actually typed in your string. There's 2 backslashes right here. Even though if I printed it up here, print it, there's only 1 backslash displayed. Only 1 backslash right here, only 1 backslash in the string by itself. If I print it though, then it actually prints a new line.
Did you store that string in a variable and then print it? I assume you did the same.
Yeah, so the question is, let's do something like t equals t backslash in t like that, store in a variable, show the variable like this. It still displays it just like you typed it in. But if I did print t like that, it actually prints it out on multiple lines. The main reason this is important, why we're talking about this right now, is because it's very important for how the split function behaves. So we were previously talking about Python spaces is awesome like this. And then if we split that, dot split, then it considers all of this white space to just be the same. It knows about that, and it will divide it up into 3 different words like this. If I have different types of white space, like maybe somebody typed in Python is, and then they hit enter and then typed in awesome, it'll still recognize that backslash in right here is white space and that this word is and awesome are 2 different things. I'm going to use the print function now to print this out right here. Print Python bunch of spaces is backslash in awesome like that. And so Python is awesome. The backslash in right here after the in before the awesome, that right there corresponds to this new line right here. And the split function is aware of that. It realizes that when you actually go to print this string, it'll be displayed in multiple different locations, that this is and awesome are going to be separated from each other somehow. And so it recognizes that that's 3 different words. That's the first major difficulty with this split function. Any questions? Yes.
So if you have a bunch of backslashes between words, it's just going to be basically like space under the white space when you split it.
If we have backslash followed by certain things like backslash t, that just adds white space.
Without printing, it's just the split.
Then that will, like, the space in the backslash t here all get combined together. It all knows that it's just a bunch of white stuff being displayed. But if I had the backslash, then it knows this is not a white space. It's not something blank. It actually is something that gets displayed. And so inside of this string down here, it shows up as backslash. And if we were to print each of the contents of this string, like print backslash, it's just a single backslash that gets printed. This is something that very easy to get confused by, especially in like a quiz sort of situation. And so anytime if there's on the quiz, you see backslashes, just know that, okay, I'm going to do this problem and then I'm going to come back and review it, make sure I didn't make a mistake. Also can just take like a lot of just wrestling with it, trying out a bunch of different examples in order to get a feel of how this works. Any questions about it so far? Okay. So sometimes when we have these strings in Python, so like let's say I have the string Python is awesome, and so make these proper sentence, Python is awesome, homework is not, like that. Then sometimes what we might want to do is not just get the individual words, but somehow like get these sentences out of this string. And if I did just like a split like this, then I'm going to get the individual words. These periods which divide the sentences up are getting kind of lost in here somehow. But we can tell this split function not to split on white space, but to split on something different if we'd want. And so here, I'm gonna, if you pass a parameter to the split function, this tells it to split anytime it finds this character right here. So here, it was the period that I'm splitting on the period, trying to find all these sentences in my text right here. And so now I get Python is awesome. Notice that there's no period anywhere. And then homework is not. And then this empty string out here. When you split on a character, it finds all occurrences of the character in that string. In this case, there's 2 occurrences in the string. And you get an element for everything to the left and everything between and everything to the right. So even though there's nothing to the right over here, we still get an element in our final list for it, which is this empty list over here. But this is the idiom for like extracting sentences out of text somehow, splitting on the periods. You don't have to split on something that sort of has semantic meaning like this. You could split on something random like the letter O. And then you just get this like pith, nuaz, mech, mu, rikizn, t. So this doesn't, like whatever you split on doesn't have to like make sense from an English or any language, human language perspective. Python doesn't care. It just finds whatever's in here and does the split. If you put a space in here, if you pass in a space instead of leaving it blank, then Python is going to be really weird, and it's going to not be indifferent to spaces. So here, see how I had this whole bunch of white space right here? Now it gives me all of these empty strings right here. That whatever you pass into the split function, it's going to find that character everywhere and give me all the occurrences between those 2 characters. So here there's a whole lot of space characters, but there's nothing between any of those spaces. So it's going to give me these empty strings down here. Each one of these empty strings corresponds to the nothingness that's between all of these spaces. If I didn't have this space character right here, just told it to split like that, then it's going to actually like split on words. There's a really common mistake that people make, not just students in this class, but like professional programmers out in the world. Splitting on a space works for what they were trying to do for their test cases that they wrote, because they only had normal looking input like this that only had 1 space between things. And so a lot of people write dot split with a space between it. But probably if you're tempted to do something like this, you probably want split with nothing inside of it like this, because that'll work on these edge cases a little bit better. A lot of stuff we just talked about. Yes.
So just to clarify, whatever character it's split on that, they also won't include.
100% correct. So the question is, will it include the character that you're doing the splitting on here? And the answer is no, it will not. If you look down here, you'll notice that because I split on the space, there are no spaces down here anywhere. There's no space in between these empty strings. These are just empty strings. And when I did the splitting on the period up here, if you look down here on the sentences that got extracted out, you'll see that there are no periods anywhere in any of these strings inside of this list. A really common thing to do is to combine the splitting with list indexing somehow. So if I have, say, Python is awesome, and I want to know what is the first word inside of some particular string, I can split on that and then index at position 0. So this Python is awesome without the index gives me this list, Python is awesome, and then with the position 0 at the end will give me just the Python out. So combining split somehow with the indexing is a super common thing to do. And if you're trying to like index what is the first word of this string or what is the last word of this string, this is the way to do it. If you don't have the split right here, again, it's just going to work on a character by character level. But if you add the split, then it's going to work on a word by word level. Any questions?
Is there any way to split it so you get each
Question is, can we split it so we get each individual letter? And this is it is possible. There's another function called the list function. We've sort of seen it in different situations before, but basically what the list function does is it somehow converts whatever's inside of it to a list in like the most simple way possible. And the most simple way possible of converting a string into a list is just taking each individual letter and putting it inside of a list like this. Let's see. So the split function is special in that it has what we'd call an inverse function. The split function has an inverse function that undoes the splitting. And this function is called the join function. Let's go back here to Python is awesome. Dot split like that. And I'm going to store this in a variable XS for us for a second. So XS now contains this list. Python is awesome. And what if I want to, so now I have a list of strings. I want to somehow combine the list of strings together back into an individual string. Well, I can do that by, I put what is the string that I want to put them together with, dot join, and then the list of things that I'm joining together. And that gets me back to my original thing. So here with this join, if I want to undo the split, then what comes over here is what's inside of the actual like splitting itself. And what comes over here is the result of the split. So I'm joining this list together right here. This list has 3 words inside of it. Python is awesome. And I'm joining them with an individual space between each word. If I change this to add, for example, a period here, then it'll put a period space between each word. Python is awesome. No period at the end, it only puts it between everything. If I want to commas, make a little listy looking thing, Python, comma is, comma awesome. So the join function commonly used with the split function to somehow like undo the splitting. And then the weird thing about the join function is that it has this weird syntax where whatever comes to the left of the dot is what you're putting in between each of these elements inside of the list. And then whatever comes inside parentheses is the actual list that you're joining things together of. Come back over to the quiz notes. Let's see, so we've done problem 8, talked about the splitting now with the join right here. So sometimes, one of the common use cases of this is that if we have something like Python, all sorts of weird like spacing in between things, some sort of weird string like this, again, \t and \in, these are white space things. If I were to print them out, then what's going to happen is we'll get a bunch of tabs, new lines, some spaces. If I wanted to make somehow like normalize a string, make it so that it looks nice, but it still has the same semantic meaning Englishly, then so that's our variable s dot split gives me that, store that in XS, and then space dot join XS gives me Python is awesome. Now with all this weird sort of spacing removed. So you can use the split and the join to sort of convert all the weird spacing back into something that's like normal and something that people would want to read. Yes.
You used the list function earlier. What would happen if you use that when there's like \t? Does it just ignore it like the print?
This is a great question. And this question leads us to what's called the length of a list. So we've talked about the length of things before. Like if we have the length of 1, 2, 3, the length of this list is 3. If we have the length of a string, A, B, C, the length of it is just the number of characters that you have inside of it. But if we had the length of something like \t, it looks like there's two characters inside of here. But when I hit enter, you'll see that it's just actually only one character, that Python considers \t to be just a single character by itself. And so if we had like a\tb, this has 3 characters. It looks like there's 4, but \t is actually just 1 character. Similarly, \n is just 1 character, \\. These are all just single characters, even though they look like they're multiple characters. And every Python function, every utility treats this just as a single character by itself. So if I have s equals a \\b like this, and I do s at position 0, well, that's going to give me an a. But if I do s at position 1, that's going to give me the double backslash, because the double backslash, when it's printed, gets printed as a single backslash. It's really just 1 character by itself. And then similarly, this b, s at position 2 is how I get access to this b. If I tried to do s at position 3, we'd get this error that there is no position 3. And so this list function, this was the actual question. If we apply the list to something, it's going to put things in the same index that they would get if we were indexing the list. Xs equals list of s. So s at 0 is the same as xs at 0, s at 1, same as xs at 1, s at 2, same as xs at 2, and so on. So it's very subtle, but very important thing to note is that these backslashes are just a single character. This week, the only thing that we're going to talk about with respect to text is English language text. Next week, we'll be talking about non-English languages, so things that are very similar to English, like Spanish, where you just have a couple accent marks in different locations, but also things that are very different from English, like Chinese, that has this whole entire alphabet, which is humongous, and we'll talk about how Python is able to deal with that. And in those foreign language cases, it'll be very important that these backslashes are treated as a single character. So we'll be reviewing this this concept here over the next week or so as well, and seeing all of its implications. And if it seems like a weird design decision at this point, the reason for it will be more apparent next week. But great question. Any other questions about anything so far? Okay, so we talked about, splitting and then joining back up. Here, splitting, here we're splitting on an individual space. So it'll be important that, you'll have extra things inside of here. And because the \t does not match the space, you're not going to split on the \t. You can split on, again, any old random character, and this will do the splitting on whatever that is. And that leads us to problem 12, the find function. So Guido von Rossum. Anybody here heard of Guido von Rossum before? He is the inventor of Python, and we all call him Guido. We don't call him Mr. von Rossum or Mr. Rossum. That's just weird. If you talk about Guido, everybody knows who that is. So Guido is the creator of Python. We affectionately refer to him as our benevolent dictator for life. Benevolent dictator for life, or the BDFL. And you'll see in all the Python documentation or various things that things are the certain way as they are because the BDFL said so. And that's just what we have to live with. So this \\, that's a single character because the BDFL said so. And so that's why it is that way. And so here, the string Guido von Rossum, let's do s.find, and we're looking for the character G. What the find function does is it gives us the index of the very first occurrence of this string, whatever it is. So the find function gives us the index of the first occurrence of the string. in parentheses. And in particular, so if I did s at position 0, then I would get this g value back like that, s at g right there. There's 2 O's in here, or 3 O's, Guido, von, Rossum, every word contains an O. If I did s dot find at O like that, it's only going to give me the very first position, the O position inside of Guido, not the von or the Rossum over here. And if I try a letter that's not in the string at all, like a capital G, again, everything in Python, if you're working with strings, is going to be case sensitive. So capital G, very, very different than lowercase g. And so s.find capital G like this, not the same as the lowercase g over there. Do that, and it gives me a -1. No, it does not mean that the capital G is the very last letter of the string. This -1 over here is, if you were to do an index, it would give us this m. S at -1 gives us this m, but this capital G does not exist, and so the way the find function works is it returns the -1. The BDFL has said that the find function is a wart in the Python language. It's one of the things that makes Python a little bit uglier than it maybe should be, because the find doesn't work like with indexes very nicely because of this -1. It would have been better for find to do something else like return none, or just return something that's not a number, throw an error maybe, if whatever it found or whatever you're looking for is not in there. But what it does is it returns -1. And that's so its behavior on an error is very different than every other function in Python. And so it's really easy when you're working to make mistakes with find because it's just different than everything else. So s.find gets you a -1. Very strong likelihood that something about that will be on the quiz next week. Any questions about this find function? Yes.
What's the difference between the find function and the index function?
Question is about the difference between find and index. Oh, gives me position 4, same exact thing that we saw before. G gives me position 0. Give me this capital G like this. And the index function actually throws this error when something is out of, like not found. Index gives an error when something is not found. Find gives -1. So index, you might not like errors, but errors exist to like keep your code from being bad somehow, from having bugs. So index is a little bit better from that perspective than the find function. Index was added because BDFL said that this find function was a wart on the language, that it returned -1. But because there was already existing code in production at different places, they couldn't change the behavior of this function, had to add a new function. Sorry.
Yes, so I noticed for S index of O, it only returned the 4th position, but there's multiple O's in Guido von Rossum. Is there any way we could use index to return all of the positions?
Question is there any way to return, use something like index to get all the positions? And the answer is by default, no. That you would have to somehow do a for loop that after you find something, then you would slice out the stuff that you found so that you're looking only in the right-hand half. And but it's not something that's built in. It also happens to be the case that it's not something that you usually like. It's not very useful in practice in the most part. All fantastic questions so far. Okay. And so this leads us to problem 14 and how things are actually stored like physically inside of your computer with text. In terms of functions that you have to know for the quiz or for any programming assignment, whatever functions are on this this quiz review, so the find function, split, join, and replace. Those are the ones that are going to be the things that you need to know. And there's a bunch more that could be useful and you're allowed to use, but those are the key ones to know. Now we're moving on from functions that you can apply to strings and talking about how strings are actually like stored. And inside of your computer, there's no like special memory for like where strings are stored versus where numbers are stored. And everything on your computer is stored as a number. Every string, every letter has a particular number associated with it. And this other cheat sheet, this Ascii cheat sheet, tells you the number for every letter in the English language, plus a whole bunch of punctuation and a whole bunch of weird special characters, most of which I don't even know what they do. The important ones over here are these right two columns where it says, let's get this thing out of the way. On the Ascii column right here, where it has the actual letter, that is the letter that's being stored in Python. And then under the decimal column over here, this is the number that corresponds to that particular letter. So the letter A, capital A, corresponds to the number 65, and the letter lowercase a over here corresponds to the number 97. Anytime that I'm doing some sort of like comparison, like checking to see whether two strings are equal to each other, what it's actually doing is checking, are their numbers equal to each other? And so when I do something like capital A equals lowercase a, Python internally doesn't even know that we're storing this as A's. It just checks, hey, is the number 65 for capital A equal to the number 97 for lowercase a? No, they're obviously not equal to each other. And so it returns false. If we wanted to do something like is A less than B like this, well, alphabetically, the A comes before B, so that should be true. And it just so happens, like the people who designed Ascii, they were pretty clever, and so they put the A number less than the B number, 65 less than 66. So it turns out that capital A is in fact less than capital B in Python. But it also turns out that the lowercase b number is not, so let's do A less than lowercase b like this. This also happens to be true, but this lowercase b number is totally different than the uppercase b number. And if I were to do something like capital B is greater than lowercase a, like alphabetically this should be true, but this right here turns out to be false because the uppercase B, coming over here, the uppercase B has value 66 and the lowercase a has value 97. So in Python, when we do these comparisons, when we do comparisons between letters, we say that comparison doesn't happen alphabetically, but it happens ASCII-betically. It kind of sounds like alphabetically, but we're really comparing by these ASCII values over here. If we have, say, a list of like, hello world like this, and we want to sort this list, in this case, it's going to already be sorted because hello comes before world both alphabetically and ASCII-betically, because the capital H right here comes before the lowercase, comes before the uppercase W. But if I were to change this to say XS equals lowercase hello like this, lowercase hello, uppercase world, and then do XS.sort, it's going to sort ASCII-betically, not alphabetically. And so world comes before hello when world is uppercase like this. Again, that's very counterintuitive, but all the uppercase, anytime you sort things, anytime you do comparisons, all the uppercase letters are going to come before all of the lowercase letters. And this is true not just of Python, but this is true of every programming language in existence. This ASCII system was developed first in the way back when computers were first being created back in the 1960s. And so you can see that it only supports things like English language text. And there's been a number of like attempts to try to incorporate non-English language into this ASCII system so that there's a number associated with each non-English letter. The system that it's only been very recently gained traction in like the last 10 or so years is called Unicode, and we'll be talking about that again next week when we talk about non-English languages. But at this point, the thing that you just need to know is this English language and being able to map these decimal numbers onto individual English characters or punctuation.
I made a list of like a lowercase b, capital H, and then a number. And then I tried xs.sort, and it didn't come out with the same output. Is that correct, or did I just type something incorrectly?
You're saying your output doesn't match my output up here?
If you type in like a letter, a number, that's different values in that different index values are basically like a number and a letter, and then a different letter, and then a capital didn't come out the same way. If it's typed in wrong.
I'll have to look at what actually you typed in after class. But yeah, the idea of like actually experimenting with things, trying things out for yourself, that is the right way to go about doing this, to figure out how these things sort of like work and line up with each other. This decimal column is the sort of standard column that, or the standard way numbers are normally represented, that you're used to representing numbers. But for various reasons, when programming, it's useful to use other base systems besides decimal, so binary, octal, and hexadecimal. If you're not familiar with those systems, then I recommend on our week 4 notes folder, there's this link to a video about using these non-decimal number systems that'll help you get some familiarity with that. But anytime you have one of these numbers, like this over here happens to be the binary representation for 64, this happens to be the octal representation for it, and this happens to be the hex representation for it. Similarly, the number 100 right here is equal to this thing right here in binary, this thing in octal, and this thing in hex. And very often in Python and all programming languages, you'll see people type in numbers in one of these non-decimal number systems. Hexadecimal is the most common. And anytime you see something like that starts with a 0x, the x right here stands for hexadecimal. So we said 0x40, that's actually the number like 64. So anytime in a piece of Python code, you see something that looks like 0x in front of it, then what you need to do in order to figure out what that number actually is you need to go to your Python cheat sheet, find out where is the, in this case, it's 40, the thing that comes after the 0x. I'm looking at the 40 right here because down here I did 0x40. The thing after the x is what you look up. And so here's the 40, go over here, it's the number 64. If we were looking up, so 0, O, 40, O for octal is the number 32 in decimal. So in order to figure that out, I have to find under the octal, oh, here's 40, and there's 32 over there like that. And then if we're doing binary, it's a B for binary. That's not a valid binary number, so you get a syntax error like this. Binary numbers only have 1s and 0s. That happens to be the number 21. Again, you figure that out by looking for 10101 over here in the binary column. There's 10101 corresponding to 21. And so again, be super important that you're able to go back and forth between numbers and all these different bases, all these different forms like binary, octal, and hex, going back into decimal when we talk about foreign language and how they're represented inside of Python. Any questions about that syntax at all? Okay, then that's it for today. Again, if you want to retake your quiz, I'll be available after class or tomorrow, Tuesday. Or if you have any other questions, available after class to answer them. Otherwise, I will be here as early as I can on Wednesday so that you can have as much time as you want on the quiz. And I'll see you all then. Office hours tomorrow are 10:30 to 11:30.
I think that's like the same.